Okay, so here we go. I am Terry Camersell, and I'm here on behalf of Creation Fellowship Santee. We're a group of friends who love to learn about our Creator God and believe that the Bible, when read properly, rules out the possibility of long ages. After 10 years of meeting in person at the Creation and History Museum in Santee, California, last week we welcomed our 100th unique CFS Virtually There speaker. You can find 4.5 years worth of our Virtually There archives by visiting tinyurl.com/CFS archives. That's C like creation, F like fellowship, S like Santee in the word archives. Dr. Douglas Walker is an engineer and researcher. He has studied multiple scientific disciplines, but most recently, he has obtained a PhD in astronomy with studies at both James Cook University and the University of Canterbury. Some of our members met Doug on their recent creation trip to South Africa. What a treat to have this PhD in astronomy along with them on that trip. He brought his Sea-Star Smart telescope, and some of our members were able to see the Southern Cross for the first time. So tonight, we're happy to have him give us a tour of our solar system.
Okay, thank you, Terry. I first of all just want to say thank you for inviting me to speak here tonight. I very much appreciate that. I hope everybody gets some lots of useful information out of what I'm getting ready to talk about. And just a little bit about me. I think as I becoming elder now, this is kind of the ministry in the latter part of my life is to try to bring the truth and news of God's creation to not only Christians but to all people that would benefit from it. Okay, so I'm going to share my screen here. Hopefully, I get the right one.
Screen 2, isn't it?
PowerPoint slide. Here we go. Yeah, everybody see that?
Yes.
No? Oh, yes. Okay. So anyway, yeah, I got my doctorate degree kind of later in life. By training and career-wise, I was basically an engineer, research engineer. I worked for NASA out of college, down on the space shuttle program in Houston for a while. Wanted to do more research related stuff, so I worked with the University of Texas system there in Austin for a while before eventually coming out here to Phoenix. I'm working for Lockheed Martin, where I retired from about 10 years ago now. So, okay, so let's talk about um, evidence for a young solar system. Okay, so here's what I'm going to go over here tonight, and we'll try to. I'm not going to like go through every slide in detail because we could like take a long time to do this, right? So I'm just going to kind of give you a brief introduction to this area, and I'm trying to be careful to make sure I reference everything to scientific references or some kind of link or something so you can look up, right? Because I know, some of this information gets attacked, and we'll talk about, the worldly approach to how we came about here a little bit later here. But first of all, I want to start off like just laying some basic foundation, like what is science, right? So pulled some definitions out of the these different references here. Oxford language basically says you're trying to understand the behavior, the physical and natural world, and then I voted through observation, experimentation, and the testing of theories. Okay, so that's very important. So everybody, the secular world likes to talk about, we're not going to talk about evolution tonight, but they like to tout evolution stuff as it being a fact and stuff. Well, it doesn't really have any observation. You can't experiment on it, and you can't test a theory about it, right? So it's really, not really science. So other ones is basically, Webster just says obtained and test through the scientific method. The scientific method basically says you have to have, repeatable results from experiments and stuff you do, right? So Science Council systematic methodology based on evidence, last from Botanica, observations and systematic experimentation. So all the common theme through here is that you need evidence, right? So science is based on taking evidence that it can see, that it can repeat. And so that's how they come up with these, natural physical laws. Okay. So laws are different than scientific theories. And so I teach some introductory astronomy courses from time to time, and I try to make sure at the first part of the course, right, I don't ever talk about, like, oh, evolution's bunk and all that. I don't really go into that, but basically I tell them, like, there's a difference between a scientific law and a scientific theory. You need to understand the differences. So I try to get them to think about that. Is what my approach is. So here's a scientific theory, right? A theory is well-sustained explanation or aspect of natural world based on hypothesis and then some facts that support that, right? So theory of gravitation, we can repeat that in the laboratory, right? So we actually the law of gravitation, right? So law of, like, speed of light, electromagnetism, thermodynamics, and such. So those are actually physical laws that we can repeat. So I'm trying to make sure that you understand the difference between a theory and a physical law, right? So a lot of this stuff is based on theories, which we're going to talk about. We're going to see all the problems with some of the theories that they have on the solar system. Okay, so the evolutionist position is that, okay, this universe is 13, I've seen 13.5, whatever billion years old, right? So I found this link here, National Center for Science Education. See, that sounds so official, right? And, supposedly has all this evidence, right? National Center for Science Education, right? So that's their position, right? The evolutionist position. We're like billions and billions of years old, right? Well, then the creationist position is that no, God created the universe exactly like he stated in Genesis, okay? And then, well, I'll talk about later about really some really good references online for creation. You guys probably already know this stuff, right? But creationist position is that no, God's word is true. We need to believe God's word, and He said He created it in 6 days, and that's what happened. I've been a Christian since I was, let's see, 18, I guess, right after my freshman year in college, really became a true Christian at that point. I've been in church ever since I was a little kid. My parents were in church all the time. But for the longest time, I never thought about, well, maybe God created, yeah, if God created millions of years, took to create a universe, who am I to tell God how He created anything, right? That's His business, right? So I never really differentiated between that. So just maybe, it wasn't that many years ago. Actually, it was when I was in New Zealand. I was working on my PhD, and I started watching David Reeves' show, Creation in the 21st Century. And at that point, I started thinking about, maybe, maybe all this evolution stuff is really bunk. And so that's what kind of put me on the path to the position I'm in today. So, okay, stellar formation theories, right? So first, we're going to talk about the sun because that's the center of the solar system. We'll go into the solar system. So here's theories I pulled out of, like, here's a NASA website right there, right? If you want this link and go to it, right? They're saying, how is a star actually formed, right? So general theory, as you go from upper left to lower right, you get this big, huge gas cloud sitting out there somewhere in space, right? And gas starts due to the gravitational attraction of the gas together, it starts, condensing down to a smaller ball. It condenses, condenses, and condenses until it gets small enough. And of course, the pressure builds up. There's the chemical, chemistry laws, like, can't think off the top of my head now. But as you decrease the volume, the temperature goes up, the pressure goes up. So it decreases to a point to where, the pressure and temperature is so high, you get nuclear fusion out of the central area of the star, and then it blows away the rest of the gas, and you have the solar system, right? That's their theory, right? So, you might have seen some of these photos here. This is called the Pillars of Creation. This is actually a nebula out in the great constellation Orion. It's now becoming a winter constellation. We actually saw that. You can see that down in the South Africa, but it's early in the morning. So I know I pointed out to a couple of folks down there. I don't think Robin and I got to you guys about it, but pointed to a couple of the folks. So this is the area inside Orion that they talk about. Oh, this is where all the stars are forming, right? So so here's more photos of that, right? So these are all credited back. If you go back to the NASA site there, this is the institute that runs the Hubble Space Telescope. So there is invisible, over to right, and infrared, and now with James Webb Telescope out there, we get more detailed infrared imagery and stuff, right? And we should I should probably give another talk later on just how James Webb has now thrown some monkey wrenches into the evolutionist theory about the universe itself. So I think it's kind of interesting, right? So anyway, so this is where they think all these stars are being formed out there, right? And this is a snapshot of a textbook that I'm actually using as a free online textbook. I'm actually using some introductory astronomy courses, right? So see the title up there. I mean, evidences of new solar systems, right? So there's a figure, planetary nurseries, Hubble Space Telescope, sections of Orion Nebula, relatively close by, whatever, right? So each image shows an embedded circumstellar disk orbiting a very young star, right? So they're saying, oh, this is evidence that stars are being created, right? But they don't actually say that any one of these is actually they're seeing a star being created. So you could take the opposite position and say, well, you know what? It looks like a big gas cloud we had back up here, right? And there's a bunch of stars in the gas cloud that's showing through the gas, right? I don't see any stars actually being formed, Of course, they talk about, the birth of the star. Here's this textbook up in the upper right up over there. So this is a section out of one of the paragraphs in the textbook, and I bolded the red, right? So, so these are now quotes. So if you go into a lot of these textbooks and stuff, they talk about these theories, but then every once in a while they'll make, they actually, come clean and basically say, well, we really don't understand how this happens, right? So see, they're saying even though all the regions such as Orion, which you just looked at, gives us clues about how the star formation begins, the subsequent stages are still shrouded in mystery, right? So they're still in mystery, They don't understand all that. So they go down here saying, kind of talk about the process again, the dust shrouded interiors of the clouds cannot be observed with visible light, blah blah blah. So anyway, they and the point I'm trying to make is like you'll see and you'll hear in the media, you'll read in textbooks that these things are facts. And when you get down and start looking at peel the onion off of them, they really kind of confess, well, we really don't know what that happens. So what's some of the problems with the theories of the origins of stars? Is that again for each star, the cloud must be dense enough to collapse and compress the interior till it gets hot and dense enough for nuclear fusion to occur. But there's a problem with that. There's this thing. Actually, when you get gas to compress, it actually gets to a point where it wants to repel all the atoms in the gas cloud, right? Not to keep condensing. And this thing called this Jeans instability, which there's the reference to it. I've got a page of references further down the line. So, but it's an mathematical calculation which shows how massive a cloud must be so that gravity can overcome the tendency of the gas to expand and then actually condense into one of these stars, right? But if you run calculations, then say, according to the Big Bang, at the time the first stars were formed, the temperature was so high that required the Jeans mass would be about 100,000 suns, right? The mass. So, sun's one mass, right? So you take 100,000 of those. And that's about the same mass as what they call a globular cluster, which is a big cluster of stars together, right? And so they're just saying basically because of that, no star can be formed in this way. And then I got this quote down here from this guy from the Harvard Center for Astrophysics saying, see, the truth is that we don't understand star formation at the fundamental level, right? So there again, you'll read in textbooks, you go take not my class, but go take some other introductory astronomy class at community college or the university level, whatever. They just quote these things as facts. All right, so that's the problems with the sun. We're going to talk a little bit more about that later. So let's now go into the solar system. So, I threw a couple charts in here. This upper left one here, I mean, you've probably seen that when you were a kid in elementary school, whatever, the solar system. 9 planets. When I was a little kid, we had 9 planets. Pluto was a planet, right? They demoted Pluto. What was that, 2003 or something like that? And there's a story behind that. They kind of did that in an underhanded way. Um, we'll keep politics out of this, right? So that's kind of a generic what all the planets are. Upper right there's it's more of a scale type of what we think the solar system looks like. The inner planets there. These I guess are astronomical units, right? So Earth is at one. An astronomical unit is a distance from average distance from the Earth to the Sun. So it's called an AU. So there's the Earth at 1. Saturn's out there at 10, so that means it's like 10 times the distance from the sun is the Earth. And then you get the edge of the solar system, a heliosphere, about 100 AUs. And then they have this thing out here called the Oort cloud. I'm going to come back to that a little bit later, right? It looks like a million AUs to these nearby stars, right? And then lower right down here is actually references to the size of different planets. Like you see how big the sun is, right? Jupiter's our largest planet in the solar system, and it's actually up visible now, right? So now, if you've ever been out, if you've never gone out to a star party, I encourage you to do that and look through a telescope and see these planets for yourself, because you can see all the pictures all the time you want, but when you actually look through a telescope, you see Saturn hanging there in space with the rings around it. It's like really cool, right? So these are the relative sizes. You see how small Pluto is, right? So that's why I got demoted, right? Okay, so theories of solar system, right? So again, accepted theories, right, from the secular world says that the Earth and the solar system formed about 4.6 billion years ago. Now the concept is all the objects in the solar system, which attached to the sun, had to be made from the same materials as nebulous, right? So we talked a little bit earlier about, a few slides back, where this nebulous cloud condenses down, forms the sun. Well, out of that gaseous cloud, you get all the planets out of the solar system, how this goes, right? There's a lot of problems with this, right? Um, Chemical problems, heat problems, dynamic problems. We're going to look at some of this, right? And then about at the bottom, I said, well, again, the Bible implies Earth is only several thousand years old. That's out of Genesis and also in Exodus, and everything in the universe was created in God's 6-day creation week. And so, that's the actual days we have now. Not each day was like, oh, well, it was like, a million years because they measured days. No, no, no. It's just a day, right? Give it up. So there's kind of like 5 different basic theories of solar system formation, and we'll briefly go through each of those. Then I'm going to show you the problems with them. So they got the accretion theory, protoplanet theory, modern Laplacian theory, capture theory, modern nebular theory. Right. So, and this is coming from the Royal Museums of Greenwich over in England. There's the link to that. So the accretion theory basically says, the sun passes through this dense interstellar cloud and emerges by a dusty gaseous envelope. There's a problem with that. How do you get the planets to form? How do you get the planets to start rotating around the sun, right? So they don't have an answer to that. So a lot of times with these theories, if they can't make it work in the current model, they'll come up with something they call it a rescue device, right? A lot of times it's like with the planets and stuff, it's like, oh, an asteroid came in and hit Neptune and turned its rotation on its side or whatever, right? It's like, well, what evidence do you have the planet was hit by an asteroid? Well, we don't see any, but that doesn't mean it didn't happen. So that was the accretion theory. The protoplanet theory basically says, dense cloud is kind of what we talked about before. Dense cloud, it starts spinning. The central mass becomes the protosun, and then you've got the rotation, so you kind of have like a pizza kind of flat disk around the sun, and they form into the planets. Okay, so that's kind of the theory. Now there's some problems with that, right? So one of the problems is small blobs should have a higher rotation than seeing the planets of the solar system, right? So the theory says you should have this higher rotation. We look at the rotation of the planets. Evidence doesn't fit the theory, right? So that's why I went back at first and talk about evidence, right? Needs to fit and make a valid theory. You have the evidence supporting that, right? So of all these theories, they have the evidence that basically doesn't support it. So down to bottom back here, right? Reference out this UK reference. However, it's not clear how the planets came to be confined to a plane or why the rotations are in the same sense. So so they can't figure that one out, right? This modern Laplacian theory. Goes back actually. It says it's modern, but it goes back to this French mathematician Laplace, and he has other Laplace equations that I've studied somewhere back in time that I've forgotten about. That all the suns form from this rotating nebula that's cooled and collapsed, right? Now, there's a problem with this one, right? The slow spin of the sun cannot be explained, right? Okay, so if this really occurred, because they run these computer models and all this, so you have, these professors sitting in university somewhere, and they have their graduate students who basically are, next to slave labor because they pay them nothing, right? They're trying to get their degrees. And so they, have them, develop all these computer models, and they run all these models, and they're trying to figure out, oh, they want this good, solid model of how the solar system formed, and they come up with all these problems. So this one has a slow spin of the sun. You can't explain that, right? Like, okay, that's a problem with that guy, right? There's another one called its capture theory, right? So basically it's saying, well, here on the right is kind of a little diagram of that, right? So you have a rogue star, right, passes close to the sun. And they don't talk about how these other rogue stars form, right? Like, oh, they're just there, right? But it passes close to the sun. So the sun's already formed, right? But it doesn't have any planets around. So we're talking about how the solar system built. So because of the gravitational attraction between this rogue star and say their sun there in yellow, it pulls out part of the gaseous part of the sun, right? And so the sun's rotating, so then all those gaseous pieces break up and they start becoming the solar system, right? So the sun interacts with a nearby protostar, dragging filament away. Low rotation of the speed of the sun is explained. Okay. The terrestrial planets are explained by collisions. Okay. And then the giant planets or satellites are explained as condensations drawn on the filament. Okay. So they like, okay, we can try to explain that stuff, right? But there's still a lot of problems with that. So that's a capture theory, right? Modern nebular theory. There's this is I think the most one that's accepted nowadays, in the secular world, right? Planets originate in a dense cloud formed that collapses again to give us the sun. Density of the disk had to be sufficient to allow the formation of the planets. Oh, my clock is striking in the background. Hope that doesn't bother you. Formation of planets, and yet be thin enough for the residual matter not to be blown away to the sun as the energy output increased. Okay, so it's a variation on the gaseous dust cloud and such. Okay, so they're saying they're basically, again, the central condensation becomes the sun. You have these dust grains that are drug out of the gas cloud. They eventually condense to become the planet. So, and after a while, the core um, rises, the slowly rotating core becomes the sun. The planets form the faster rotating cloud. Okay, so that's the modern nebular theory. So basically, what I'm saying is, conclusion wise, for all these different theories, right? There's been many attempts to develop these theories for the origin of the solar system, and so, but there's problems with all of them. Okay, and so here's another quote, right? And I should have referenced this quote. I need to go back with the reference to this. So it's so it's coming out one of those references that we do believe, however, that we understand the overall mechanism. Okay. Um, and then they're saying the sun and planets form from the contraction part. Okay, let me repeat a lot of this stuff. So that's the basic theories of the solar system. Okay, so here's some diagrams, basically kind of saying the same things. Right, we go from upper left there. This is the nebula hypothesis theory there. Right, you get the sun, you get rotating portions become the planets and stuff. And see, they get all this really detailed, right? They got all this stuff really detailed. Kind of like, if you go look at evolution, the evolution of man, they got all these really detailed drawings and stuff about how man evolved, and each stage, he looks more like a man than a monkey and all this stuff, right? They can really elaborate with those. So the same thing goes on here, right? And so these theories are just pushed relentlessly. Okay. So on the left over here, this is a textbook I found. This guy, Professor University of Oregon. He teaches astronomy. He's an observational astronomer, right? So if you go look at his stuff online, it's all evolutionary. This is what it is. Neil deGrasse Tyson's a guy that's it's kind of taken up from Carl Sagan there on the right. You're probably familiar with Carl Sagan. Evolutionists, right? Oh, yeah. I remember reading one time about Carl Sagan back when I was a kid, and he was alive. He made some statement. There was some interview with him. He made some statement. He says, you know, um, there's no evidence that I've seen that points to a creator. And when I read that, I'm like, well, that's all the evidence I see does point to a creator. How can you come up with that opposite conclusion? But it goes back to your viewpoint, right? So they're starting with a secular viewpoint. There is no God. Everything here is natural. So we got to explain everything we see in the natural realm, right? So that's what they spend their lives, their whole careers, all their energies trying to do, which is sad because Satan's very good at his lies, right? So he's deceived all these people into believing there's not a God, and keeps deceiving them for their whole life. But the Bible also says, "If you seek me, you will find me," says the Lord. So they just never really truly seek Him, right? Another section on introductory astronomy textbook. So here, origin of the solar system, right? So here's the objectives of this section. Explain the importance of collision in the formation of the solar system. So that's one of the main rescuing devices they love to use is this collision in the solar system. All right, problems with the current theories, right? Sun's, so I go through a bunch of these things, right? Sun's axial tilt. If the sun and planets were formed by this collapsing nebula, then the sun should be spinning in the same plane. Okay, right. However, this axis is tilt a little over 70 degrees away from the ecliptic. So the ecliptic is a plane in the sky. And it's where all the planets basically rotate around the sun. And so if you go outside and look at the night sky, there's a certain, it's called ecliptic in the night sky, where all the planets are going to appear in the night sky. So you'll never see the planets around the North Pole because that's not where the plane of the ecliptic is. So the sun's axis is tilted like 7 degrees away from the ecliptic, right? Jupiter's orbital plane is most of the planetary mass and angular momentum outside of the sun. So it's inclined about 1.3 degrees from the ecliptic. So that's still leaving about a 6% difference, right? These tilt of the planets are usually not explained by invoking collisions, or usually explained by invoking collisions, but this would not apply to the sun. So again, they want to explain a lot of these anomalies they see in the solar system by they have some rogue asteroid or something flying through the solar system, hits one of the planets, knocks it off its axis or whatever, and so they explain it like that. Okay, so more problems with these current theories, law of conservation of angular momentum. Just, as a skater pulls in their arm, momentum equals mass times velocity times distance. They spin faster, right? So in the formation of a sun, the same effect would have occurred, right? Contraction to form the center form of the sun. And this would cause the sun to spin very rapidly, but our sun spins slowly while the planets move rapidly around the sun. So the sun has over 99% of the mass of the solar system, but it has only 2% of the angular momentum. Okay, so there's a problem there, right? So this pattern is directly opposite the pattern predicted for this nebula hypothesis, right? We just talked about that, right? So they try to solve this problem. A well-known solar system scientist, Dr. Stuart Ross Taylor, which I don't really know, admitted when discussing the angular momentum problem that a predictive theory of nebula evolution is still lacking. See, again, you catch them off for a coffee or something when nobody's looking. They're like, yeah, we really don't understand all this stuff, right? They admit it. Problems with rocky planets. So again, all the evolutionists, astronomers believe the rocky planets arose from the collision of dust particles. Okay, so you got that disk around the sun, and it's collapsing down. It's forming the planets, right? So out of that disk of gas and stuff, you get like things collect together, become actually dust particles, and they start sticking together. And as you get more masses together, they start heating up, and they melting and form larger blobs of molten rock and stuff like that. So all these blobs together start to form larger and larger to form all the inner planets, which are Mercury, Venus, Earth, and Mars. However, if you look, right, research, right, so we're back to the labs and the guys and the graduate students, shown the rocks would not melt, okay, but mostly would simply zoom past each other, collide and recoil like, snooker balls off of a table, right? Okay, so that's the problems with the rocky planets in the inner solar system. Here's some problems with the gas giants, right? So the solar system is broken up into kind of two parts. Again, the inner solar system has these rocky planets, right? We just got through naming those all the way out to Mars. And then you have a gap between Mars and Jupiter, and you have an asteroid belt out there, which they think was a failed planet to be formed or whatever. Then you have the gas giants in the outer solar system: Jupiter, Saturn, Uranus, and Neptune. And you go further out, and you have a little bitty Pluto floating around out there. Uh, so the gas giants, so we're just talking about Jupiter and Saturn here, are far enough away from the sun that the ice could condense, right? So they're mainly icy type worlds. So you have to have strong enough gravity to suck that gas in. But Jupiter's core turns out to be too small to do this, okay? And they're running simulations, to try to, figure out what's going on there. Simulations are showing that the solar nebula would dissipate before the core had a chance to grow big enough, so it's unstable. So when then in the other planets out there, Uranus and Neptune, they're even more acute than even for Jupiter. And so they, again, graduate students running computer simulations have never been able to explain planets as big as the two giants forming that far out from the sun. The problem with their current theory, retrograde motion's another current theory, right? Nebula hypothesis predicts all the nebulas spiral inward, and they're rotating in the same direction. Venus rotates in the opposite direction. It's called retrograde rotation. It's like, well, how did that happen, right? And again, so the way they try to get around that is that they have like an asteroid flying through, or some rocky planet or something flying through the solar system, hits Venus and knocks its rotation in the opposite direction. Well, they've also discovered a comet with a retrograde orbit. And so, again, if everything formed out of this original gas cloud, that shouldn't be in a retrograde orbit, right? And so here's a statement from one secular article, and said that's it's inconsistent view that planets are formed by, again, the condensation of dust from a disk surrounding a newly formed star. Okay, more problems. We keep going, right? Methane is missing in some of the planets, right? So Titan's a moon of Saturn. Titan has a thick atmosphere made of nitrogen, a bunch of other gases there. Interesting. So they sent out this space probe out to Saturn some years back, Cassini mission, and the actual probe landed on the surface, and they found this mystery that scientists trying to model Titan's atmosphere calculate should contain no methane, okay, but it should have been used up tens of millions of years ago, right? So the solar system's actually 4.5 billion years ago. All the methane should be gone. But they find methane there, right? How'd that happen? The young sun was too cool. So here's a problem with the sun and back, right? It's called the faint Earth-sun paradox. Again, evolution believe, cells formed from chemicals in the Earth 3.8 billion years ago. At that time, according to their computer models, right, the sun's life cycle has given off about 30% less light energy than it does today. Those are supposed 8 and 9 supposed to be references there. And the Earth would have been much cooler. So so Earth was probably looked like a ball of ice, right? So basically life couldn't survive on it. So how did life evolve on a ball of ice? So sun was too cool. Io, a moon of Jupiter, is too hot. So Jupiter, and then you can see there on the right, this is taken from one of the space probes, is showing a volcanic activity on the planet Io. This is one of the first things discovered like in the late 70s there. So Io has all this sulfur across its surface, a lot of volcanic activity. Scientists, before they got the space probes out there, they thought it would be volcanic. However, it's a lot hotter than what they anticipated, right? Some of that's explained by the orbit of Io around Jupiter, because Jupiter is so large of mass, it actually affects the orbital characteristics of it. Tidal forces squeeze and makes it hotter, but it's a lot hotter than what they can explain by that. Uranus is another problem, right? The orientation of Uranus's magnetic field is unusual. Most of the magnetic fields are approximately aligned with the rotational axis, not with not with Uranus. It's offset from the rotation axis by like 60 degrees. Okay, so how did that happen, right? And this little inset on the right here is Dr. Russell Humphreys, and now he's with Ministries International, and he's still alive. He was a scientist at one of the national labs here. Maybe it was Los Alamos, I'm not sure. But he's a creation scientist. And so before they sent the Voyager spacecraft, this is like in the 80s, past Jupiter and Saturn, before it got to Uranus, he made a prediction. So, the computer models are saying, oh, Uranus, has this type of magnetic field, right? So he went back to the Bible and said, well, if actually God created the solar system from water, what would the magnetic field look like, right? So in 84, he made his prediction on the magnetic field of Uranus based on the amount of magnetic decay that would have happened on a planet in 6,000 years. Okay. So this is before the Voyager spacecraft got there. When Voyager 2 got there, it confirmed his prediction, and all the scientists' predictions were wrong. Okay. Now, you don't hear anything about that in the textbooks, right? This creation scientist made a correct prediction on the magnetic field strength of Uranus, right, before the probes got there. This is one of my favorite ones here is problems with comets, short period comets. This is one, how do you pronounce that name, that just came into, just left the inner part of the solar system where we could see it, right? And these are time lapse. I didn't take these photos of the comet. Some of these were taken around here in the Phoenix area, I believe. So very pretty comets, right? Comets have these long tails and stuff, right? Um, the problem with comets is that if you have the solar system again, 4.5 billion years old, you shouldn't have any comets, right? Because comets come in, circle around the sun. And so this one showing you right here in the lower right is another comet, right? And so that tail is actually part of the comet being burned off by the solar wind of the sun. So every time a comet comes around the sun, it loses part of its mass because the sun burns it off. Okay, so after so many orbits of a comet coming around the sun, it's burned away. It's gone, right? And so if the solar system is 4.5 billion years ago, we shouldn't see any comets because they should be gone. Well, obviously we see them. Okay, so what else is going on, right? Well, if we go back to that diagram at the beginning where it talks about, I showed you the solar system and it had that Oort cloud out there. That's a hypothetical. I think I hear something here. That's a hypothetical cloud on the outside of the solar system that they made up by some guy back in the 50s that says, oh, these are where all these comets are. And they're just sitting out there from the creation of the solar system or the evolution of the solar system. And every once in a while, a star passing by or something perturbs one of them and sends them on a path around the sun, and we see it, right? And this is the source of all these comets. Well, I interviewed for a teaching position here in Phoenix when I got back from New Zealand, and they had me do a little blurb or whatever to see if my teaching style. And I took this example, right? And I said, well, okay. And I'm telling the class, what observational evidence do we have of the Oort cloud? It's like nothing, zero, niche, right? We have no observational evidence. So there's something there, go back to the scientific theory, right? We have no evidence of all, but if you go back and read again textbooks, they make and state a fact like, oh, well, all these comets come from the Oort cloud. Well, there is no Oort cloud out there. So all these problems disappear when we basically say, you know what? God created the whole universe 6,000 years ago, created the sun with the properties suited to our needs, exactly like we needed, right? Very stable source of energy for us and all life on Earth. Okay, so again, it's your perspective of how you're looking at how things came about. Evolutionists look at through the eyes of their, it's called the worldview, right? Glasses. I've seen some other talks, and they look at the worldview through these glasses of there is no God. Everything has to be explained by naturalistic, mechanisms and such. And so they work really hard, and they're really smart people, right? I'm not saying they're not. They're very, very smart people, but they've been deceived. And so they spend all this time and energy working on all these models, trying to explain like how the solar system came about, trying to explain Venus's, rotation, reverse, retrograde rotation, trying to explain the tilt on the axis of Uranus, right, and all this, and the sun and all that, and they just can't explain it with their computer models. So. Here's some creation websites. I put these in here. You're probably already familiar with some of these. Answers in Genesis, that's Ken Ham's up in Ohio, whatever it is, right? So they have a whole section there. And I've taken all this material I've taken is from these sources. So I probably could be properly to go back and I do reference all these sources, but I need to credit all these sources too. So Answers in Genesis is one. Institute for Creation Research, ICR, is another good research center. They're based out of Dallas. There's Answers in Genesis again. Comet, so Evidence for a Young Universe. Okay. And then Creation Ministries International, which is I think it started out of Australia. Now, there's a U.S. counterpart here, but that's a link to that there. So they have all kinds of references on not just the solar system, but Big Bang Theory, other space activities, evolution, all this good stuff. Here's another good website here. This guy Spike Parsons. We're trying to, get him to come and speak at the February astronomy day that David's going to have here in February, but he said he's out of the country. So
Yeah,
he has
he's
a lot of
probably
excellent.
in Israel.
I'm
He
sorry.
spoke for us before. He came on this forum.
Ah, excellent. Okay. I've heard of all of his talks, but I've never met him. So I want to meet him because he has a bunch of great videos that talks about the solar system and stuff, And then he worked for Lockheed Martin at the Space Command. I, retired from Lockheed Martin, and I'm now working for the Space Force. So we have a lot of things in common. So I'm anxious to meet him. So that's a great website there. Here's my other references. I think they go on for several pages. Additional references here. These are Creation uh, um, Ministry International websites, I believe. And that was the last slide. And I'm counting down to 4 seconds. So how about
That
that,
was
Robin?
pretty good. You did a great job on that timing, and that was a great presentation. I enjoyed
Let
that.
me. Oh, I'm stop sharing. Okay.
Yes,
Yeah.
I see the
So
golden
anybody got
matrix.
questions, comments, discussions we want to talk about anything? Or
So
I
what
think
we'll
do we
do,
have time?
oh yeah, we've got lots of time, which is really
Okay, great.
unusual because the
I
last
shouldn't
few speakers
have
have
talked so
gone
fast
over a little bit.
then.
I should
Yeah,
have
you
texted
were
you.
just breezing through it.
Yeah, I know. I should have said, slow
Well,
down, slow down.
Robin read me the riot act. She says, "Don't you dare run over the time." I said, "Okay, well."
Well,
No,
after the last two
I'm
weeks, yeah,
teasing Robin.
you caught me off guard. I'm like, oh no, scrambling. So here I am. Okay, so
no,
we do have some questions. Yeah, go ahead, Robin.
I just want to, so what we'll do, Doug, is, we won't, we'll keep recording and we'll give you some questions. I
Okay,
really can speak better than this. I don't know what's wrong with me. Uh, so Terry will ask you the questions, we'll have you
sure.
answer, and then when we've finished a certain amount of questions, then we'll stop recording, stop live stream, and we'll make it a free for all.
Okay. All right.
All right, since we are still recording and live streaming, if you could all please be sure to keep your cameras off and your microphones muted, that would be really great.
Do I need to do that too, Terry?
Oh no, please.
You're going to have a
Please.
hard time answering questions if you're muted, Doug.
Well, thank you. Want my camera off? Or?
No.
Okay.
No. Okay, so here we go with the question. So the first one,
Okay.
if a secularist is insisting that stars from the nebulas, that stars form, Robin?
Let me go ahead and ask my question.
Yeah,
That
go
was
ahead.
my question. So I belong to an astronomy club, and they're all very insistent when we have astronomy night, that there are stars forming in the various nebulas or the
Right.
star forming regions.
Right. Yep.
And they're brainiacs, and they just tell us, and I get them to admit that nobody's ever seen it, but they keep saying, well, there's baby stars in there that we can't see yet. What would you say to
Okay.
somebody?
Show me the money. Show me the evidence that you got a star farming. You can come up with all your theories, but I want to see observational evidence of a star farm. Until you show me that, it's your theory. It's not a fact, it's your theory.
Great, thank you.
Sure.
Hey, good job. So next question, wasn't the Oort cloud first invented? Well, I think you covered this one, Rob. This is Robin's again. So she's asking if it was invented in 1932.
Was that it in 32? I'm trying to remember. So
Well, I had
it was,
asked the question before you said 1950s, and then I couldn't remember, and I could have gone to Google, but I didn't. So somewhere
okay. We
between the
can,
30s, but it's
yeah,
invented
yeah.
in.
So it might be the 30s. I'm trying to remember now, but yeah, some astronomer came up with, why are we seeing these comets, right? Oh, it can't be because, again, if the solar system's 4 in a billion years old, we shouldn't see any. Well, we see them obviously, right? They're all coming. So how do we explain those? Oh, well, there has to be this Oort cloud. And it's named after this guy Oort, right? And you think he was a German astronomer. Is that Oort name? So and it's just a theory, but it's what gets me is that it's always stated as fact in all the textbooks, in all the lectures you hear. Everybody just states, "Oh, yeah, it came from the Oort cloud." Well, okay, show me the observational evidence for the Oort cloud, right? Well, we don't have any. Well, then, okay, how can you say? I mean, I can say that there's Santa Claus out there throwing snowballs in, right? I mean,
No,
they're like,
Santa
well, that's
Claus is
just
in the North Pole, and we've just never seen him,
well,
but
yeah,
we
they're
know he's
saying, well, that's
there.
actually stupid. I'm like, well, there's just as much evidence for that as it is for your theory, right? You know, so
That was great.
I mean,
So, on line
yeah,
with that, Brian is now asking, since we have a protective field around our Earth, is it possible that there could be an Oort cloud field that protects our solar system that God maybe put?
okay, could be, right? Possible,
But we've never seen it.
but we've never seen it, right? See, so there's different kinds of astronomers, right? There's astrophysicists, which I'm not even, I can't even do that stuff. And then there's the theoretical cosmologists, and I've got a photo somewhere of a gal that was down there with me in New Zealand. She's got this whiteboard with all these equations on them and stuff. I'm like, well, what does this mean? So they got the cosmologists and they're trying to figure out how the universe came about and all that stuff. I tell everybody I'm an observational astronomer. Like I take observational, images of like variable stars and planets or whatever, and then I base my, um, I've written, paper stuff based on light curves of stars. Well, I'm actually looking at the light curve of the star, right? Not some theoretical thing, right? So I'm an observational astronomer, so I have a hard time when people say, well, this, so and so. I'm like, well, show me the evidence, right? You know, until I see the evidence, and again, it's just your theory, and I could probably come up with one too. And you know, why isn't my theory just as good as yours about how Santa Claus is throwing snowball comets off the North Pole? So
Well, I was thinking about that question that Brian asked. Um, it's like God could have used, millions of years to create the earth, but we know that the earth is only 6,000 years old, give or take. And we wouldn't need that Oort cloud because we already have comets in motion, and he plans on
right.
bringing it into the earth quite quickly or soon coming up here. um, I don't think we would need the Oort cloud. But in my opinion, Brian, and I am not even astro anything. It's possible, but I'm thinking not.
So you're right. I mean, if God created everything 6,000 years ago, there's plenty of comets He created at that time. We don't need the Oort cloud, right? Because they haven't all burned off yet. I heard some. If you go back to an evolutionist, about man, there's some astronomer out there that's in California. I forgot his name. I probably wouldn't mention it if I could remember it. But he's a Christian. I heard him actually talk at a Christian businessman's fellowship here in Phoenix years ago. And only the Lord knows a person's heart, right? But he tries to fit in, the solar system and the creation of the universe with millions of years and,
Oh,
you know,
Hugh Ross.
Hugh
Hugh Ross,
Ross. Yeah, okay.
that's
We should
his
mention,
name.
yeah, we never mentioned it. Yeah. So anyway, but then I heard somebody say, well, if man evolved up, if God evolved man up to these humanoids, right? You'd have all this death and destruction and everything up until the time of Adam. But the Bible clearly says, when God created everything, it was very good. He didn't talk about death and destruction before Adam actually sinned, right? So you can't reconcile those two, you know.
Exactly. Very.
Okay. Well, Jeff just wants to point out that if the Oort cloud really exists, the Voyager spacecraft doesn't have a chance.
Well, maybe because Oort cloud could be not very dense, right? So I mean, it's just like they flew the spacecraft through the asteroid belt in the inner solar system, So
But wouldn't the Oort
and
cloud have to be really, really big? If there was an Oort cloud, wouldn't it have to be really, really big to hold all the comets?
yeah, but it's
Just
so far out there, so it's a huge area. It's a big sphere, right? It's not just in a plane. They think it's in this big ball around the solar system.
okay.
I just find it funny, as like I was trying to, emphasize at first, between what's scientific fact and laws and theories. Um, Scientists,
They have their fairy tales as well.
well,
Yeah.
right, and they have their theories, right? And yeah, they're fairy tales about. I mean, they're trying to explain it, right? So, getting to their viewpoint, right? They're trying to explain what I see from a naturalistic viewpoint, right? So they have all the computer models run like, this computer model won't, the solar system can form like that. Well, our model's not right. We got to tweak it, and maybe something ran into Venus, right? So they come up with all these, and Parsons does a really good job in his videos about explaining these rescue devices they always come up with to try to, save their theories, right?
Yes.
Yeah. Okay. So uh, uh, Cheryl is asking about what your position is with Space Force and how you're treated by them as a creationist.
So right now I'm working, try not to work much longer. So I'm working as not a consultant because I work for a defense contractor. What we're doing is that, we have satellites up in orbit that are looking for missile launches against the U.S. from China or Russia or whatever. And those satellites have been up there for a while, so they want to replace that system. So I'm doing computer modeling and stuff for some replacement of those systems. Um, the guys I work with are Christians, okay, all except one, I believe. And my project lead is a strong Christian because the other night when Trump finally was, announced Trump won, he texted me, he says, I told you he was going to win, right? So, um, but, we haven't really talked about it. And, I guess I don't go around announcing it or whatever, right? And if someone asks me directly, it's like, yes, this is what I believe, right? Because I had somebody in my weekly church Bible study, right when I first got back from South Africa, Robin, and they were asking me, I said, well, it was with a creation group. She goes, well, what do you mean a creation group? I said, well, we all believe that God, created, and there's no evolution. She's like, you don't believe in evolution? I'm like, no. Do you? And so she's one of the members of our church, right? So even, in the church, right, everybody's been indoctrinated since they're, can talk, right? Oh, evolution's true, evolution's a fact. Well, it's not a fact, right?
They get the
So,
kids
yeah,
with the dinosaur books. Dinosaurs are so cute and they lived 65 million years ago.
right.
Well, with the Lord's blessings, we might be really outing you tonight. If this goes viral, So, but so
Now,
Diane is asking if you know anything about Chandra. Now, I don't know if I'm pronouncing that correctly. It's Chandra. She said she saw a YouTube video about it. Are
Oh,
you
the
familiar with
Chandra
that?
telescope. Yeah.
Okay.
the Chandra telescope.
Yeah, that's the one
Uh,
that they were going to discontinue, but now they're going to keep it on.
oh, okay. Is that? Yeah, I'd have to go look it up. Is that an X-ray telescope? No.
Yes, yes,
Let's
it
see.
is.
Oh, it's an X-ray
Mm,
telescope.
yeah.
Okay. Yeah. I mean, from the Earth's surface, we can only observe optical range of electromagnetic spectrum, visible, and radio waves. So that's why you see these big, huge radio telescopes, and because they're longer wavelengths than the optical. So the other parts of the spectrum, which you have going all the way from long to short, you have infrared, and then you have radio, visible, and then you have ultraviolet, X-ray, and gamma rays, right? So, as you go through the spectrum there, you get shorter wavelengths, higher energies, right? So X-ray and ultraviolet, from ultraviolet all the way to gamma rays, you can't see from the Earth because the atmosphere blocks the absorption. So that's why they put X-ray telescopes in orbit. And so a lot of these objects out there, you view them in the visible spectrum, and they show some characteristic, and you view them in infrared and they show different ones. So that's why James Telescope is mainly infrared. Well, it is infrared telescope. And um, Chandra is X-ray, so they'll show the object emitting X-ray. So a lot of times you can tell a lot of different information about the stellar object and the different frequencies.
Interesting. So Steve is asking if the Earth really is old, wouldn't
Yeah.
that mean that the church was wrong for centuries about the global flood and the age of the Earth?
Okay. If the Earth is really billions of years old, is that what he's asking? Or
Yeah, he says, doesn't an old Earth mean the church was wrong for centuries? Because the church, what he's saying is that the church didn't believe in old ages. So
oh,
if all of a sudden it came out, if there was some kind of evidence, which obviously we know that there isn't, for long ages, then it would mean that the church was wrong about the global flood and the age of the earth. For
For
centuries,
like,
they were wrong.
yeah, for like 1800 years.
Yeah.
okay.
So
I think
I
I
don't,
understand what he's saying. So,
well, so okay, let's move on to the next question, and we'll make this our
okay.
last question for the recording
Okay.
portion of it. But Jeff is wondering if you're familiar with Apophis,
Apophis.
Apophis. Okay, asteroid expected to have a near miss with Earth within the next 5 to 7 years.
Okay. Uh, no, I mean, I might have read about it somewhere. It seems like every couple months or some asteroid's going to slam into the Earth, whatever. So, so I think I have heard of Apophis though, but so next 5 years are supposed to like be a
5 to 7
collision.
years. Um,
Oh, okay.
Tom Horn wrote a book about Apophis, wormwood. Apophis means bitter,
Oh,
just like wormwood, and
yeah. Um,
that's in the Bible. And they're
yeah,
stating that's a possible way that a third of the Earth could be destroyed. I mean, it's all
could be.
speculation and conjecture, but it is headed this way.
Okay.
But Jeff, I don't think they said until um, I don't want to say because I don't remember. So, anyways,
Well, let's go ahead and wrap things up. Now, Doug, I don't know, is there a way that people can find you, or if they have questions to follow up with tonight, or I'm not
Sure.
sure that
Yeah.
if you have a book that you can promote or whatever we can
No,
do
I don't have a
to
book.
thank
So
you.
actually, I thought about writing a book like on evidences of the inner solar system, but I haven't done it yet. So, yeah, I mean, I can give you my email and you can pass it out to the members that are,
yeah,
that are members that
we
are, yeah,
we
yeah,
won't
you'd like
say it
Yeah,
to.
on camera though. We can put it into the
Yeah,
chat.
yeah, okay. Yeah, yeah,
yeah.
yeah. If people want to, yeah, sure, absolutely. I'd be happy to talk to anybody about any of this, right?
All right. Well, tonight we've been blessed to have this presentation with Dr. Doug Walker. So if you do
Well,
have any
thank you.
questions and follow up, please reach out to us at creationfellowshipsantee@gmail.com and we'll forward your questions to him. And if you'd like to see the speakers that we still have remaining for 2024, you can visit tinyurl.com/CFS archives, C like creation, F like fellowship, S like Santee, and the word archives. And with that, we're going to go ahead and end the recording for tonight.